The surprising part about AI governance is that the bottleneck is not intelligence. It is coordination across institutions, across borders, and across the systems that run society. In 2026, most AI governance is still local. It lives inside a single organization as policies, committees, and review checklists. You see model approval boards, access controls, red team tests, monitoring, incident response, and legal compliance. Those controls matter, but they do not scale cleanly. They are hard to compare across teams and harder to enforce across jurisdictions. What is missing is a true control plane, not a policy memo, not an ethics statement, and not a dashboard you cannot audit. A civilization-class governance system would be enforceable and machine-auditable. It would constrain what AI can do, authorize what it may do, log what it did, and evaluate whether it behaved. It would also support revocation and remediation when something goes wrong. Think of it as a control stack for AI-mediated decisions, the way identity and payments have stacks today. That framing leads to the first high-impact finding. Explainability by itself is not control. In practice, explainable AI tools help reviewers inspect some behaviors in bounded technical contexts. Taxonomies of explainability concepts are now mature enough to support audit workflows. Visual methods, like GradCam for vision systems, can show what parts of an image influenced a model. Yet none of that guarantees legitimacy or safety or accountability. Some explanations make humans feel confident without improving their decisions. So the hard question becomes practical, not philosophical. Which explanations actually improve audit outcomes rather than just reviewer comfort? The second finding is even more operational. The most important governance artifact is not an explanation. It is a structured evidence packet. Other fields have already solved versions of this problem. Systematic review reporting disciplines, like Prisma 2020, make claims checkable. They force authors to say what they did, what they included, what they excluded, and why. Clinical trials show another pattern, a culture of regulated evidence generation and safety reporting. Guideline production in medicine shows how expert consensus can be structured, published, and revised. The lesson is straightforward. High-stakes systems earn trust through disciplined evidence, not persuasive narrative. For AI, an evidence packet would be standardized and machine legible. It would describe the model, the intended use, and the authority being delegated. It would include evaluation results, known failure modes, and monitoring plans. It would also include escalation paths, rollback procedures, and the record of affected party review. When a regulator, court, insurer, or parliamentary inquiry asks why a system was deployed, you answer with that packet. If you cannot produce it quickly, you do not have governance, you have paperwork. Third, adoption tends to outrun participation, and the education sector made that visible. Systematic reviews of AI in higher education found educator participation underrepresented. Later analysis of large language models in education highlighted governance challenges around assessment and oversight. The pattern generalizes well beyond schools. When affected practitioners are not in the design loop, governance becomes brittle. You get symbolic human-in-the-loop checkpoints with no time, no authority, and no access to evidence. Then failures arrive, and everyone is surprised, even though the warning signs were structural. That leads to a simple design rule. Some roles must remain human accountable, even when machines do the preparation and execution. Approval, escalation, appeals, exception handling, and rollback authority cannot be faceless. They need named owners and clear procedures tied to liability and legitimacy. Now zoom out to the cross-jurisdiction problem. A fourth finding is that comparable incident reporting is possible, but only with persistent measurement architecture. Global health offers a useful analogy. The global burden of disease work maintained comparable metrics across 204 countries and territories over decades. That did not happen because people agreed on one report. It happened because they sustained taxonomies, denominator definitions, revision cycles, and uncertainty reporting. They built pipelines, not press releases. AI governance means that same discipline for incidents. Incident has to mean roughly the same thing across divisions, agencies, and countries. Severity needs a shared scale, without erasing local context. You also need comparable denominators, like exposure, affected population, or decisions processed. Otherwise, every dashboard becomes a self-serving story, and underreporting becomes the rational strategy. Fifth, governance at scale requires early detection of localized failures. Systemic disasters often start as local anomalies, hidden in high-dimensional telemetry. Here, adjacent methods matter, even if they look like pure analytics. UMAP, published in 2018, is used for dimensionality reduction and clustering. It can help reviewers see clusters of similar behaviors, intents, or incidents at scale. Local indicators of spatial association, formalized in 1995, is about hotspot detection. In governance terms, it is a way to find where problems are concentrated by geography, institution, user group, or operational unit. These are not governance systems by themselves. They are primitives, tools that help a monitoring layer notice trouble early enough to act. Governance has to move from local documents to enforceable infrastructure. That infrastructure depends on identity, authorization, provenance, audit logs, evaluation harnesses, revocation, and escalation. It also depends on open agent protocols and delegation records, so that authority does not blur into discretion. Without those building blocks, agentic systems will spread faster than control can follow. It is also worth being blunt about the risk envelope. Civilization-scale governance can fail in distinctive ways. False legitimacy is one, where the existence of a control system substitutes for real accountability. Automated coercion is another, where enforcement becomes fast, opaque, and unappealable. Capture is a persistent threat when the same actor monitors, evaluates, and enforces without independent review. Metric gaming is predictable once metrics become targets. Cascading revocation failures are especially dangerous in critical infrastructure, where a revoke action can propagate faster than humans can interpret. So what should a present-generation leader do before any deep horizon future arrives? Treat governance primitives as capital infrastructure, not as a legal appendix. If a vendor cannot export audit data, you are renting trust. If a system cannot be revoked quickly, you are accepting unmanaged tail risk. If model updates ship without an evaluation packet, you are flying without maintenance logs. Make the governance demands concrete. Require machine-readable logs for tool use, delegation, model version, input class, output class, and human overrides. Require documented limits on explainability claims so XAI supports audit rather than replacing accountability. Design incident taxonomies that can be shared with regulators, insurers, auditors, and peer institutions. Separate monitoring, evaluation, and enforcement authority, so no one group can quietly launder risk. The long horizon arc is plausible, but not guaranteed. Near term, between 2026 and 2050, governance becomes a procurement and risk layer for enterprises and governments. Mid-horizon, between 2050 and 2100, interoperable cross-border stacks may emerge, with shared authorization and reporting. Long horizon, governance could become embedded directly in infrastructure and public administration. Deep horizon adds a hard physical constraint, light speed delay, which makes real-time central authority impossible. In that world, provenance, consent, and revocation still have to work, even when coordination cannot be immediate. One line to carry forward is simple. If you wait until AI capability forces the issue, governance will arrive as crisis management, not as design.